Then question 4 was our second question of analytical geometry, where we had a quad. Okay, more specifically, they told you it was a parallelogram, and they told you those are the three vertices that we have in coordinate form, and then D is unknown, it's X, Y. And of course, later on, there's various different ways you can find D. Okay. Our first question is asking us to find the length of BC. Okay, BC, we know it's distant formula. Okay, so you can substitute your two coordinates. Remember, a pair goes together in front and a pair goes together at the back. And then you should be getting as an answer 5 square root 5. Or you could have also written 11,18. Okay, then the gradient of AB. Okay, AB, okay, we have the coordinates, we have the coordinates. So it's a simple case of just substituting in again. And then when you simplify that, it's negative 6 over negative 6, or if you swap the coordinates around, 6 over 6. So your answer for the gradient is 1. I ask you for the equation of CD. Okay, CD. Now, we don't have this coordinate. And to find an equation, we need a gradient and a point. Okay, we have a point, but we don't have a gradient. But they told you it's a parallelogram. So one of the things we know about a parallelogram is that the opposite sides are parallel and equal. And we did find AB already. Okay, we said the gradient of AB is 1, therefore the gradient of CD is also 1. Okay, if they ask you for a reason, you say opposite sides of a parallelogram. Then we can go substitute. Okay, and you can substitute the coordinates of C in here, which is negative 1, 10. So 10 and negative 1. Okay, so y is equal to x plus 1 plus 10. In other words, x plus 11. Okay. You could have also, of course, used the other formula where you first find C and then substitute back in. Then, determine the coordinates of M, the midpoint of BD. They're telling you M is the midpoint of this line. Okay. But because we know our properties of parallelogram, we know it's also the midpoint of CA. Okay, we don't have D, so we can't find that point. But we can find the midpoint of CA, right? And then it's the same midpoint. So you substitute in your points. Remember, a pair goes together, both in front, both in back. And then you should be getting negative 3 over 2 and 2. Or, of course, this could have been negative 1.5 or negative 1,5 also. Okay, so you could have also found this with inspection because they didn't tell you what the gradient, because they didn't tell you what the midpoint was anyway. So if you found with inspection, that would also have been fine. Okay, because it's halfway between the two x and halfway between the two y's. And if they ask you for a reason, you say because the diagonals of a parallelogram, or because the diagonals of parallelogram, or you can say because the diagonals of parallelogram bisect one another. Okay, in other words, they have the same midpoint. Okay, and then our last question, hence or otherwise determine the value of x and y. Okay, now there's various different ways you could have found this x and y. Probably the most logical in this instance would have been we just found m. There was a reason why they asked you if you found m. Okay, so this is also the midpoint of that. That's one of the ways you can do it, and that's the way I'm going to show you. But of course, you could have looked at like what's happening with gradients. Okay, how is the y changing? How is the x changing? And then similar. Okay, so if you use the midpoint one. Okay, so we found the midpoint was negative 3 over 2 and 2. And we have the coordinates of b, which is 4 and 0. Okay, then you go multiply with this one. You go multiply with 2. So x plus 4 is negative 3. And then you go minus the 4. So x is negative 7. Here, you go multiply with the 2. So y is 4. Alternatively, you can ask yourself what is happening here. So from this 0 to that negative 6, we are minusing 6, right? So you take 10 minus 6, okay? And then what's happening from the 4 to the negative 2. We're also minusing 6. So we also minus 6 this way. So then we'll get minus 1 minus 6. So we have negative 7 and we have 4, which is the exact same answers we got earlier. This is transformation, but if they ask you for a reason, transformation is not a reason, it's a technique, right? So what is actually happening here is you are using the properties of the parallelogram. You are using specifically the fact that the opposite sides are parallel. Okay, the change in y and the change in x, that's gradient.